Welcome to episode 4 of the ACTNext Navigator podcast. I'm Adam Burke. My guests today on the show are Kristin Stoeffler, Laurel Ozersky, and Yigal Rosen. In 2021, an ACT creative thinking assessment, the first of its kind, will be a part of the international test called Pisa. I want to read a quote from Andreas Schleicher, the Director of Education at OECD, which administers and develops Pisa. He says, "The dilemma for education is that the kinds of things that are easy to teach and test have also become easy to digitize, automate, and outsource. The goal of education should be to develop first-class humans rather than second-class robots." In 2021, students from about 70 countries will take the test called Pisa, which assesses 15-year-old students in mathematics, science, and reading, and a fourth innovative domain that changes with each testing cycle. The ACT-developed creative thinking assessment will be that fourth element in the 2021 testing cycle. Here's Mr. Schleicher again, quote, "A fundamental role of education is to equip students with the skills they need in the future. Creative thinking is a necessary competence for today's young people to develop as societies increasingly depend on innovation to address emerging challenges. PISA 2021 will take international assessments into a new phase by gathering data on young people's creative thinking skills." That's Andreas Schleicher. He works for OECD, which administers the PISA test. In addition to PISA, ACT is developing its own coursework called EDU 2050 that encompasses some of the cross-cutting capabilities in our ACT holistic framework. What are cross-cutting capabilities, or CCCs as we call them? These are thinking and learning skills like collaborative problem solving that we discussed with Saad Khan, Dave Edwards, and Proveen Chopade in our last two episodes of ACTNext Navigator. CCCs, cross-cutting capabilities, are foundational skills that support learning in all subjects. On today's show, we have Yigal Rosen, Kristin Stoeffler, and Laurel Ozersky. Yigal and his group are leading much of the research and development in support of ACT's transition to a learning company. Kristin is a creative thinking specialist. She's working on the 2021 PISA assessment of creative thinking, and she's also developing ways to foster students' creative thinking skills for EDU 2050. Kristin is also an artist. Laurel Ozersky is a former math and science teacher. Her work on EDU 2050 is about how to develop computational thinking. As she'll talk about, computational thinking is not just for computer programmers. It can be used in historical research, for example, or in solving societal problems like food waste. So let's get to it. Here's the show. Laurel and Yigal are joining us online. Kristin and I are in the ACTNext studio, which is actually just a conference room. So we're going to start with Yigal and find out a little bit about what Learning Solutions is. So welcome, Yigal, and you can introduce yourself a little bit and then tell us about Learning Solutions.
Hi, Adam. Hi, everyone. I'm Yigal Rosen. I'm the Senior Director of Learning Solutions at ACTNext. As you all know, ACT is going through a major transformation to really lead with innovative learning assessment and navigation solutions. Our Learning Solutions team at ACTNext is supporting this transformation with the design, development, and actual implementation of some of the innovative prototypes and solutions at scale. So among our major projects are, of course, the innovative assessments, both national and international. Our team is building the most innovative international assessments, the PISA 2021 creative thinking assessments are going to be delivered to students students in many countries in 2021. But of course, as Learning Solutions team, we lead with learning science, learning analytics, and the actual design of innovative learning experiences, really focusing on the what we call ACT cross-cutting capabilities, or 21st century skills: creative thinking, computational thinking, collaboration, communication. All of those skills are very, very critical for success in life and career. There is a very much lack of learning solutions in this context, and this is really our major focus and the focus of this conversation and the presentation in the conference next week.
Pisa is a huge test, and this is a big thing to do the creative thinking. And it's the first time, right, that creative thinking's been assessed in Pisa, or any major test, probably.
This is correct. And of course, we work with OECD that is leading the effort, and we design, develop, and test different prototypes. As you mentioned, this is the first time that creative thinking is going to be administered and developed in such a large scale. So our team, in of course collaboration with the other teams at ACT and with external partners, we designed, developed, and tested those prototypes in multiple countries, in multiple languages and cultures. So this is a very major endeavor that we are delighted to lead with the OECD and the other partners.
And now, can you talk about EDU 2050 and what that means and what it means for ACT?
Sure. So EDU 2050 is coming really from the spirit of education for the future, for future life and career success. So in EDU 2050, we are focusing as the first offering on creative thinking and computational thinking. Those are going to be launched in September 2020. We are developing those courses, those offerings in, of course, online settings, so students will be able to take those, to practice those skills and take the assessments. Those courses, those credentials are going to be, of course, validated, tested with a large number of students that also contribute. We have also teams of students that contribute to the development of those challenges, of those innovative assessments are going to be part of this offering. So just at a glance, this is going to be self-paced practice and credentialing solution for high school students that will be used, of course, to practice those critical skills, but also enhance and create certain differentiators for the college admission purposes.
Cool. Let's go to Kristin and Laurel. So tell me if I'm wrong here. Kristin is doing creative thinking. Laurel is doing computational thinking. Is that right? Mm-hmm. It's kind of divided. So you and we'll get to each of those things. What is creative thinking and what is computational thinking? Measuring creative thinking. Should we do that? How do we do that? What does that mean?
Oh, that's a good question. We should do that, absolutely. And we can do that, which I think is what we sort of set out to make happen with, or to figure out with PISA 2021 creative thinking assessment design. And that really was an adventure in creative thinking in and of itself. But I think the key for us in terms of measuring that is really and how you define it. And people get pretty squirreled up when they think you're trying to measure creativity, and they should, because no one should ever be told that they aren't creative or creative enough. That's pretty ridiculous. But we all have the capacity to tap into our full creative potential. But many people have conflated then along the way creative thinking with creativity, and they just aren't really the same thing. So it really comes down to how you define it.
And so how do you define it? What is creative thinking?
So we've defined creative thinking as the capacity to extend beyond conventional boundaries to create unconventional and valuable solutions. So in the course, what we're really looking at are students' abilities to both identify what is conventional and start to understand in the context of that what then would be unconventional. Oh. And there's a lot of evaluation that occurs then within that, and that you need to understand the nuances of that in terms of your own maybe biases and your own, how society is looking at those boundaries, and then how you personally might be creating boundaries of your own. And in making all of those sort of implicit processes more explicit, we're able to then create activities where you can practice doing that. Like, what would the common answers be to this question or to this challenge, and then understanding what makes those answers common, and then that allows you to think more about, okay, what would an answer that not many people would come up with look like then for this question or challenge. And so then you're starting to build on these processes along the way. And that's sort of what the EDU 2050 courses are set up that way, and that hopefully we can start to help people through the process of cultivating those skills. We do this so automatically that I think we don't even have a sense of it when it's happening, that we're actually doing this creative thinking thing. But in order to apply that maybe in new situations or to new contexts, it's helpful to go through those very explicitly and say, okay, this is the part where I should probably think about what is conventional. And based on what I'm understanding there, what would unconventional things look like? Where would those knobs be and those little variables? And the degree to which you can do that, then you can start to sort of better understand, what boundaries have I created? And how can I move beyond those in order to better create something that maybe hasn't been thought of before, or come at this from an entirely new angle. So that's where it becomes, the EDU 2050 work is more than just assessing creative thinking. It's helping people understand that process in a way that they could, and practice that process really in a way, and apply that process in a way that you can start to sort of cultivate those skills and move that beyond the course into your real world. And a lot of these 21st century skills are about awareness.
You're basically helping people become better at creative thinking, is that right?
Well, that's the hope with EDU 2050. There are some specific skills and processes that support our ability to approach a challenge in a way that we come up with a solution that other people might not think of, and that's really what we're exploring with that course.
So, Laurel, what is computational thinking?
Well, put simply, computational thinking is a method of problem solving. You use computational thinking skills when you're trying to efficiently develop solutions if you have a given problem, and you're more likely to use computational thinking skills if you want your solutions to be reusable or transferable to other contexts outside of that in which the initial problem was presented to you.
Okay. How is computational thinking different than traditional problem solving?
So this is where the computational piece comes in. We know that computers are very good at solving a variety of different types of challenges and problems, but they do require a computer programmer to come in and write a piece of software that sets the computer up to be best suited to solve the given problem. When we employ computational thinking, we're pulling from both the skills that the programmer uses in designing that software, as well as the methods that the computer is employing when it's solving said problem. So we see this computational aspect coming from two sides, from the perspective of a programmer writing software for a computer, and from the perspective of a computer doing what it does best when it solves problems.
So is a computer necessary to do computational thinking?
And you might think so, but actually, no. There are plenty of instances when utilizing a computer is necessary and helpful, but the skills required to employ computational thinking don't require a computer. If anything, they require you to think like a computer.
Think like a computer. What does it mean to think like a computer?
To a computer, everything is ones and zeros. Something is turned on or it is turned off. But a computer programmer can use their various talents and skills to take a problem of any type and abstract it into a more general set of smaller problems, if you will, or or abstracted into broader problems that can be translated into a very, very basic level of thinking.
Beyond computer science, how does this skill apply?
Computer science is inherently coupled with computational thinking. We might say that a computer scientist practices the computational thinking skills. But when you break down these individual skills into smaller, more manageable sub-skills, if you will, we see that those sub-skills are relevant across all sorts of domains. In fact, this is why we include computational thinking in the cross-cutting capabilities. So if computer science is a subject area, computational thinking, as the name suggests, is more of a thought process that encompasses the skills. And in that regard, I would say there are infinitely many scenarios when you can use any one of these computational thinking skills. We've distilled the idea of computational thinking into three main categories, which are working with data, algorithmic thinking, and computational modeling. And while these sound very specific to computers and computer science, if we again break these down into sub-skills that are required, we'll see that we can apply them to different subjects. So for instance, one subset of working with data requires students to make informed decisions about data collection. How do they collect necessary data given a set of constraints? Or how do they evaluate the validity of a source? And while these definitely come up in computer science, these are also integral skills when doing historical research or putting together a paper in an English language arts class.
How do you measure the skills of computational thinking?
Well, as Kristin alluded to earlier, when talking about creative thinking, it's about how you define them. So we've designed a competency model that is driving the development of our computational thinking courses in EDU 2050. And this model is aligned to standards set forth by the International Society for Technology and Education, ISTE, or Digital Promise, which is a nonprofit organization focusing on the practical use of technology in the classroom, as well as next generation science and engineering practice standards and Common Core practice standards. So this model we've designed doesn't put forth any new standards, but rather it builds on the foundation set by these existing standards and describes more specifically how an individual can demonstrate mastery for any of these particular skills. A good example that I like to showcase of computational thinking applied to a non-computer science domain is a very common problem in our world, and that is food waste. In the United States and many other countries as well, food waste is a problem. We have people with not enough food, and then we have lots of food that gets thrown out on a daily basis. And so the skills involved in computational thinking apply perfectly to this scenario, because we can start by breaking down the problem or decomposing the problem into a subset of smaller problems, and then we can abstract these problems and see how can we tackle any one of them more broadly or more generally. And of course, in tackling this problem, you need to do research. You need to design data collection. You need to face a variety of different constraints and work within them. You need to evaluate the validity and the reliability of the data you've collected. And that's only in the very initial phases. As you go on studying this problem, you need to, of course, analyze this data. And then you need to move into this algorithmic thinking piece where you propose a solution that can automate different parts of the problem itself. So let me illustrate this example. This is an opportunity to incorporate computers in computational thinking by designing a program that can quickly and easily keep track of how much food is coming into a food store or supermarket, how much of that is being sold, how much of that is being wasted. And in doing that, you can design the program to look for various patterns and make perhaps various comparisons or find relationships between, well, we notice all of the bananas that are coming in past Friday afternoon tend to get wasted rather than bananas that are sold on Mondays. We can look for these sorts of patterns and use that to influence our decision making going on. after we break them down into their component parts, and after we try to design a more automated process, we need to iterate on this, and we need to continue this cyclical process of collecting more data and finding new and innovative ways to organize that data and to analyze that data in order to better address the problem. This is where computational thinking has a lot of overlaps with creative thinking, because as you can see, there isn't one right solution to any of these big problems. And so because there are so many solutions, we implement or apply our computational thinking skills to help us work through and tackle these challenges in a very systematic way.
Before you joined ACTNext, you taught high school, and did you use computational thinking in your classroom, and how?
Absolutely. This was something I highlighted a lot with my students, was that because computational thinking is a set of skills and not one particular skill, it can be applied in so many different aspects of daily instruction. And so I taught science and math, but this is again true in many other subjects. For my students, I taught lower level physics, and so one of the things that I really focused on with them was the data collection as well as the pattern recognition. We would do various labs using different digital resources. You may be familiar with PhET simulations. This is a digital tool from the University of Colorado at Boulder, which enables students to partake in physics labs digitally when they may not have the resources to do so in the physical classroom. And so my students could use this tool to design their different studies depending on what their goal was. And they would collect data and they would analyze it. And based on that, they would try to predict future outcomes using the existing patterns they recognize. They would then try, if their pattern holds or if their prediction holds, they should be able to redesign their experiment in a certain way and use that to justify their that their prediction or that their model or their data collection was correct. And so all of these subsets are skills required for computational thinking.
Yigal, do you have anything you want to add or kind of wrap up about learning solutions and where the team's going, or comment or anything about Kristin or Laurel's talk?
Performance.
Sure. First of all, it was really great to hear. The way Kristin and Laurel introduced the courses, the competency model, the design principles. Maybe the one important observation is that in our work in learning solutions, we, of course, design those learning and assessment experiences and create the underlying, technological capabilities that enable the design, development, and deployment of those solutions at scale. So we are leveraging the open source OpenEdX LMS and the studio with certain enhancements that we are making in order to enable some of those solutions for EDU 2050 specifically, but also more in general for the innovative learning and assessment solutions at ACT. Of course, working with our partners both in the K-12, higher ed, and the workforce setting to really lead with those solutions in different contexts, and of course different techniques and different tools that are being developed are always tested in different settings and optimized, as I think both Kristin and Laurel mentioned. It's part of the competency model in those skills that we are measuring, but also part of our own work in a process of design, development, testing, and optimization over time to really lead with those effective learning and assessment solutions.
How do you assess your assessments or your program? How do you decide this is a good way to do this?
A lot of, R&D, research and development, goes into the design process. At multiple times throughout the design process, Kristin and I will host focus groups with students of different ages and backgrounds to get their feedback on the direction we're taking with the course. Going forward, once we open a beta version of the course, we can of course collect tons of data, which we'll very carefully analyze. And oh look, there I go using my computational thinking skills to analyze data. We'll analyze the data that we get back from our initial alpha and beta testers for the course, and we'll see and any feedback they can provide us as well. And we'll use that to iterate on the courses and continue improving them till we feel like the course really does represent the goal and that the students are getting the intended outcomes from participation in the course.
Thank you, Yigal, Kristin, and Laurel. And thank you for listening to ACTNext Navigator Podcast. This has been episode 4.